These next questions cover aircraft performance for the private pilot oral exam check ride. Number 88. How is density altitude calculated? To calculate density altitude, obtain the field elevation. Number 2, the barometric pressure. Add if it's below standard, or subtract if it's above standard to obtain pressure altitude. For example, if the field elevation is 2,000 feet and the barometric pressure is 30.00, you will subtract 80 feet, 30.00 minus 29.92 times 100 from 2,000. Number 3, line up the pressure, altitude, and temperature on your flight compass to find density altitude. If temperature is above standard, density altitude will be greater than pressure altitude. The opposite will occur if temperature is below standard. Number 89. What are the typical performance charts found in a pilot operating handbook? Performance charts common to all POHs include takeoff, climb, cruise, landing, maximum glide chart, and the density altitude chart. You should be proficient with each of the performance charts in your POH, be able to use each chart and explain it to your examiner. Number 90. How does density altitude affect airplane performance? High density altitude has a noticeably negative effect on aircraft performance. First, because the air is going into the engine is not as dense with high density altitude. The engine does not develop as much power. Second, the propeller is an airfoil and does not develop as much thrust in the thinner air at high density altitude. Third, at high density altitude, the wing is not as efficient and therefore requires more airflow to produce the same amount of lift as would be produced at lower density altitudes. Thus, high density altitude has a negative effect on your takeoff roll, climb rate, and cruise performance. Number 91. What are some factors that affect takeoff performance? The common factors that affect takeoff performance are density altitude, the weight of the aircraft, wind speed and direction, and the surface of the runway. With a higher density altitude, the aircraft will have a longer takeoff roll. Increased weight also increases the takeoff roll. If the wind speed is high and it is close to a headwind, the ground roll will be reduced because of the increased relative wind. Finally, a soft runway surface will make the takeoff roll longer. Number 92. What is maximum range and what is maximum endurance? Maximum range is the maximum distance an aircraft can fly on full fuel. Maximum endurance is the maximum time an aircraft can fly on full fuel. Number 93. What is the definition of best glide speed? Best glide speed is the point in the drag curve in which total drag is the lowest, or L/D max. Number 94. What are some factors that affect landing distance? The most common factors that affect landing distance are wind speed and direction, the runway surface, and the weight of the airplane. The stronger the headwind, the slower the airplane's normal speed at landing, and the shorter the landing distance. A poor runway surface decreases braking efficiency. A heavier airplane has more inertia and requires more landing distance. Number 95. Define center of gravity. The center of gravity is the point at which the airplane would be balanced if it were possible to suspend it from that point. It is calculated by dividing the sum of the moments by the sum of the weights. 96. How is the center of gravity for an airplane calculated? The center of gravity is calculated by dividing the airplane's total moment by the total weight. Total moment is the sum of the products of the weight of each item in the plane, for example, the occupants and baggage and fuel, multiplied by the arm. The arm is the distance of the item from the datum. Number 97. What are some of the effects that being over gross weight can have on an airplane? Being over gross weight is illegal and very dangerous. It can increase the takeoff and landing distance, decrease climb performance, cause possible structural damage, and accelerate metal fatigue. Number 98. Where are the measurements taken for the computation of the center of gravity? The center of gravity is computed from the reference datum, which is defined by the airplane manufacturer. It is frequently the firewall or the leading edge of the wing. Number 99. What are the handling characteristics of an airplane with an aft center of gravity? An airplane with an aft center of gravity is generally unstable. It will fly at a higher airspeed, but it may be impossible to recover from a stall or spin. Number 100. What are the handling characteristics of an airplane with a forward center of gravity? An aircraft with a forward center of gravity is generally more stable than one with an aft center of gravity. It will fly at a slower airspeed, more drag, and it will stall at a higher indicated stall speed. Number 101. Why should a weight and balance be calculated with both current conditions and with zero or low fuel under the given conditions before departing? Before beginning any flight, you must compute a weight and balance with the current conditions. However, as fuel burns during a flight, the center of gravity moves. To make sure the center of gravity will stay within limits the entire flight, you should calculate a theoretical weight and balance with no or low fuel as well. Number 102. Define moment. A moment is a tendency that causes an object to rotate about some axis. Axis AXIS. Moment is the result of the weight of an object multiplied by its arm. Number 103. Define arm. Arm is the distance, usually in inches, from a reference datum to the center of gravity. Number 104. What is the difference between the moment and the arm? The arm is the distance from the datum to the center of the item for which the moment is being calculated. The moment is the product of the weight of the object being measured and its distance from the datum, or arm.